Thank you for viewing this recorded Reliable Automatic Sprinkler Company webinar. Should you have any questions regarding this presentation, please feel free to contact Reliable Technical Services at 800-557-2726 or email us at techserve@reliablesprinkler.com. For upcoming webcasts and an archive of past webcasts, please visit reliablesprinkler.com/webcasts. Once again, thank you and enjoy the presentation.
Thank you everyone out there for joining us today from beautiful upstate South Carolina. We have a lot to get through today. About an hour into building this presentation, it became clear that it's going to be a challenge to get through in the 50 minutes. We are going to do our best. I have an alarm set for 5 minutes before the hour. We'll take a break at whatever point we are at that point to answer some questions. As Lindsay mentioned, we will be answering questions in the meantime as they roll in through the chat function. If you can't stay until the end, as Lindsay also mentioned, please return and catch the tail end of the presentation on the recorded version. So as always, we are going to start with the disclaimer. The opinions expressed are those of Reliable Sprinkler, and even more specifically me, and may not necessarily reflect the opinions or positions of the National Fire Protection Association. Also want to point out real quick that we're not going to include every single change made to this edition of the standard, but it reflects the content is going to reflect what I deemed most important. And then a final reminder, there is content in the annex that has been changed or added. Valuable information always to be found in the annex. We're not going to be covering that as well. So just real quick, the development process, always like to remind folks to get involved in your industry. Here's how you do it. There's a link right there to the how-to process. The current edition of NFPA 13 is open for public input until June 1st. If there are things that you don't like or don't understand, please become involved in that process, and let's help make this document the best that it can be. It's a large document, well over 500 pages now, over an inch thick. Everybody has had their hands on it. You can see how big it's getting. It is not done by just one set of people. There are 4 basic committees. You can see them listed there on the screen. And then the correlating committee as well has the responsibility of making sure that information that crosses between, for instance, 13, 13D, and 13R is correlated. And you can find the members of those committees listed in the front of the book. So I'm going to go from front to back in the book. We're going to start with definitions. At the bottom, you can see the committee that's responsible for these definitions. It'll help you kind of put it in context. First one off the bat here is building height. You would think that would be, something you could find on the architectural plans, but it needs to be defined. And in this case, it's defined solely in the context of the purposes for seismic protection. It does not have, it's not applicable to things about determining whether the building is a mid-rise or a high-rise or fire department access. It's simply for the purpose of seismic protection design. Smooth ceiling. In the previous edition, there was some very subjective language that stated free from significant irregularities, lumps, etc. So now that has been more clearly defined as those irregularities, lumps, or indentations greater than 4 inches in depth. So we have something now we can actually measure. The term drop was not previously defined in the standard, but where it was used in the standard seemed to be in line with the historical definition of a vertical pipe supplying 1 sprinkler from above. So now that is what a drop is, 1 sprinkler. If it's more than 1 sprinkler, it's going to be a riser, and that has been defined in the standard for quite some time. Exterior projections. So again, previously undefined in the standard, this is just an excellent 11-word example of a long committee debate over what seems to, again, be a fairly well understood concept. However, without the words projection beyond an exterior wall, it could have meant a vertical rooftop projection, and that was never the intent for what is now clearly defined as a horizontal projection from a building wall. Grade plane, we defined a little bit ago the building height, and in there was a reference to grade plane. So now we have to define what the grade plane is, and you can see there that for a sloped grade or an irregular grade around a building, it represents the average of that ground level across the whole perimeter of the building. So again, this is not to apply for building code or apply for building height for building code reasons, fire department access, etc. This all again ties back to that seismic design issue. Ordinary hazard group 1. So now we see a return to language that was in the standard before, but if you go into the 2019 edition, you would read something along the lines of where the quantity and combustibility of contents does not exceed the amount of miscellaneous storage of class 2, 3, 4 plastics, tires, etc. So in 2019, for some reason, the committee referenced ordinary hazard group 1 and tried to tie it to a miscellaneous storage design is really what happened. That language of class 2, 3, 4 plastics, etc., to me seems more hazardous than even an ordinary hazard group 2. So we're now again seeing a return to some historical language in terms of moderate stockpiles, etc., etc. The term shadow area we've had in the standard for a while, but there was not a reference to the floor area. There was a reference to the area of a sprinkler, and when you talk about the area of sprinkler discharge, you're now talking in a 3D world, which is really, really hard to measure right on the floor. So again, the idea, and now again very clear, is that the line of protection on the floor, if it's blocked by an obstruction or whatever, that's what we're talking about, not the spray pattern itself, just the footprint on the floor. Electrically operated sprinkler, now defined in the standard, and you can see it on the screen there. They are here in a limited way. There was a recent SFPE presentation where Mark Fessenden with JCI talked about electrically operated sprinklers. So they're again now defined. You're going to see additional information as far as installation and maintenance and things like that in this edition and in future editions of NFPA 25. So speaking of the SFPE, they're a great additional resource for training and contact hours for your CE credits. And a reminder to tune in if you can to the SFPE channel on April 6th. Reliable will be doing a presentation on the design of large dry pipe systems. Sprinkler system, again, has been defined a couple editions ago. We for a long time did not know what that definition entailed. It has been corrected a little bit. The term water control valve, we're going to see, has been clearly now defined in terms of something along the lines of an alarm valve or a dry pipe valve or a deluge valve. So you don't have to have a water control as defined water control valve on your system, but you do have to have a control valve. So simply they took the word water out of that definition. That was the installation committee that did that. Valve has been defined, and then is more specifically defined in other locations in the definitions as a check valve, control valve, water control valve, so that would be your deluge valve, etc. Now we're going to jump out of the definitions and work our way through, again, through the standard in order here, and chapter 4 entitled General Requirements. So The first thing that we run into in general requirements for some odd reason is miscellaneous storage and things like that. So what this particular statement is intending, it's a very awkwardly worded statement in my opinion, but what it seems to be intending to say is that if you have solid shelves in areas defined as miscellaneous storage, they do not need to be sprinklered. In most cases. And the requirements for sprinklering solid shelves are found way out in Chapter 20. But again, for miscellaneous storage and incidental to the use of the building, all of that good stuff, solid shelves not required to be protected per 20.19. Protection criteria for miscellaneous and low piled storage. So those two rolled together, but they're quite different in terms of what they are. It's not necessarily a new section in the standard, but just be aware that when you start talking about miscellaneous and low piled storage, that you will be limited in building height. You'll be looking at things like OH1, OH2, EH1 designs, and anything above 10 feet, right? So miscellaneous storage is going to go up to that 12-foot mark in a lot of cases, 5 foot for Group A plastics, etc. Once you're over that 10-foot mark, you're probably going to be putting a level of in-rack sprinklers into those storage occupancies. Water supply treatment. So this is another interesting one, probably needs cleaned up a little bit. For some reason, MIC and general corrosion, the ways of treating that have now been split out. Like we like to see things rolled together when we have repeat information, which we do in this case. There are 4 methods to address MIC. There's 6 methods to address general corrosion. There's a lot of I want to say 4 of them are basically the same. So it needs cleaned up a little bit. And in reality, it's more talking about pipe treatment than water supply treatment. So again, look for some cleanup along those lines in the future. Chapter 6, installation underground piping, and no, that is not a typo. That is the title of the chapter. Why it's not installation of underground piping, I have no idea. But again, just wanted to let you know I didn't make that mistake. We'll look at getting that corrected as well. So we've known for a long time that we cannot run pipe for long distances under slabs inside a building. The committee and everywhere else, for some reason, again, changed the word under to the word beneath, except when they added this this clarification, we still see the word under. But the key thing here again is you cannot go 2 feet into the building and then 90 feet to the left along the wall and say, I haven't gone more than 10 feet into the building. So the word cumulatively now is to account for, again, that horizontal breakover that might occur around a grade beam or something like that. So just be aware that it's not 10 feet in from the wall, it's 10 feet cumulatively under the slab. Restrained joint systems. Again, a simple change here, adding the word listed in front of these particular types of connections. Now, to me, it would make sense that that would always be understood to be the case, but without the word there, what that tells me is that at some point there was a conflict between what an AHJ thought and maybe an underground contractor or fire protection contractor thought. So there was probably a little bit of locking of horns here. Remember now that AHJs are part of the public, and someone has come in and said, all right, let's clean this up. And we are now going to very specifically require listed connections on our underground piping arrangements. With regard to keeping records of testing, and this is going to essentially probably start cutting across all aspects of record keeping, all the way out into the NFPA 25 world. We're now going to see an acknowledgement that we're heading into the future and that electronic records will be with the AHJ's approval an accepted way of keeping records rather than everything being in paper. We all know the fallacies of trying to keep shop drawings and submittals and things like that in those nice clean riser rooms. So you'll see similar information along these lines in NFPA 25 as well. Flushing of piping. Again, a couple of additional requirements or allowances thrown in here where you cannot meet the maximum flow rates that you need. For instance, if you're trying to flush an underground main up to a fire pump, that fire pump is providing that extra energy into our system. All it's saying here is that you will flow the maximum amount of water that you possibly can in from that system to flush that main out. And then we see again, along what I just mentioned, the suction piping added to that requirement. And then an acceptable method now is what's considered forcible swabbing of the pipe. And there are some additional requirements and constraints and so forth surrounding what they consider forcible swabbing as that acceptable method. Moving into Chapter 7, Components and Hardware, Temperature Characteristics of Fire Sprinklers. So I had made a note that this seemed to be a solution in search of a problem here. For some reason, the thought was to split glass bulbs and links out into two separate tables. The only change that I could come up with was for ordinary temperature sprinklers, and then the allowance now to have 155-degree bulbs permitted in areas that are up to 120 degrees ambient temperature. Okay, and we still see that the 165 ordinary solder links are limited to the traditional 100 degree Fahrenheit ambient condition. Perhaps there's some idea that glass bulbs are, more durable in those temperatures for long periods of time. We would debate that ourselves. At the end, it doesn't really matter for us. I just don't like the idea that we've now essentially given building owners the permission to take that temperature in those buildings up to 120 degrees if they're unoccupied, if there are glass bulb sprinklers in there. Doesn't make a lot of sense to me, but it is what it is. Welded pipe and fittings. We have had the allowance to do field welding in the past with with the appropriate safety measures and requirements for welding procedures, etc. But there was not a specific allowance to fix leaks. And so now we have this allowance that the repair of weld leaks, in addition to field welding, is now approved, provided that you follow, the appropriate safety measures, welding procedures that are specified in 7.5.22 and 7.525. Automated valves. I don't remember this one coming up in the committee meetings. Why it was added, I can only presume that someone may be looking to bring a product into the market, or has run up against a situation where an automated valve, perhaps a motorized control valve of some sort, that maybe was deemed unacceptable by the standard. Now essentially is allowed, provided they're listed, provided they have the indicator, etc. And as well, they must be able to be operated manually. So that is now available to us. Whether or not those listed valves exist, I don't know, but we do have the opportunity. Water flow alarm devices. So this was an interesting debate in the committee, long debate, a lot of smart people in there trying to figure this stuff out for the industry. The requirements to get a water flow alarm now have been split into two, one for mechanical / water motor gong type activities, and one for electrical alarms. The 5 minutes allowance that has been historically in there for the water motor gong remains, and for an electrical alarm has now been reduced to 100 seconds. It was my understanding that the thought here was that the device itself would trigger within 10 seconds and could have a retard as long as 90 seconds built into it. So that's how we get to that 100 seconds. So, you know, kind of more appropriate almost to the NFPA 25 world in terms of testing, but obviously from the get-go, we've got to meet these requirements for new systems. You're going to see in NFPA 25 in the next edition some more information about the inspection and testing devices in the automated world. Potter Electric, for instance, has that flow switch that, you know, basically triggers itself without flowing water. Been a huge emphasis on saving water and things like that. So we now have some language about those devices and the installation of those devices. And you can see the words on the screen. It must be as effective as a manual examination, right? Trying to you know, align this with what you would get in today's world. It shall produce the same action, right? The vane in the water flow indicator must move, and then if the device fails, it must send a signal to the 72 panel that says it's not working properly. So again, we're going to start. This will build in the next few cycles until it's fully vetted. But again, watch for some more information in NFPA 25. This statement on the screen: residential sprinklers installed on dry pipes, of course they shall be listed for dry pipe applications. But if you look in 2019, what it says, residential sprinklers shall be listed for dry pipe applications. Very, very poor wording. Because what it says is that I don't care if you're using them on a wet system, they shall be listed for dry pipe applications. Again, poor wording that's now been cleaned up. When used on dry pipe, obviously they need to be listed for dry pipe. And secondly, in the last standard 2019 edition, that statement fell under the heading of dry pipe system water delivery of all places. So again, a cleanup of the document to make that in a better spot. The manifold test connection. So you guys remember the table that came out a few cycles ago where you can do 1 orifice, 2 orifice, 3 orifice, 4 orifice. You know, your water delivery time descends a little bit into that 40-second range, etc. It seemed that that table was built for the fluid delivery program, and I believe that it's still applicable to that. However, it's been moved into its own section, so it's essentially been extracted out into its own area. And underneath what it says is that a system meeting the requirements of this section, in other words, if you build a 4 manifold or a 4 orifice manifold, you shall not be required to also meet these other 2 requirements. What those 2 requirements are: 8232 is a 60-second water delivery, and 8235 is the option to calculate the water delivery using the programs that are available. So it's very interesting. I don't know if it was the intent, and this will be an interesting discussion in this cycle. If I manifold it, I don't have to do either of those. That's technically the wording as I understand it. So we'll see if that holds and whether or not that was actually the intent. High water level protection. So again, this has been around in the standard for a long time. Exactly what it meant, hard to figure out. However, it's been cleaned up a little bit here. With the new external reset dry pipe valves, and various manufacturers, including Reliable, have these, it is possible to reset the clapper before the system is drained. I think this is intended to prevent an owner, for instance, from going into the riser room, hitting the reset button, and thinking he has reset the system. Because if you trap that large column of water on top of that dry pipe valve, it's not going to operate properly. We need a way to say, essentially, that you have just done that. That's what this section is, in my opinion, is intending to do. Over time, it's possible as well, even on a system that hasn't been tripped, due to accumulation of water from condensation, hydro testing, etc., to get that water built up on top of the clapper. So we also going to see language that exists in the standard for trying to, somehow remove that water off the top of that system. Again, it's in the follow-up to this section right here. System types and requirements. We are going to see in the standard an allowance to use a C factor of 120 on dry pipe systems and double interlock pre-action systems when nitrogen is being used as the supervisory gas. And the way that that's going to be allowed, we can't just say, hey, we're going to put it on and turn it off, right? That's the fear. Somebody's going to put this generator on, they're going to turn it off. So again, we have to put the rules down. If you're going to want to use that C factor of 120, it has to be a listed generator, a minimum of 98%. We're now told how much leak rate is allowed, 1.5 psi per hour. The system, the generator has to be able to maintain that. Even if it doesn't exist, it's got to be able to maintain that. You've got to be able to verify the concentration. The generator manufacturers have all the devices and the technology to be able to do that. And then again, kind of rolling into the NFPA 25 side of things, it shall be properly maintained, and there will be additional information on what that looks like in the future in NFPA 25. Air pressure values for single interlock pre-action systems, the requirements for double interlock systems being a minimum of 7 psi to basically remove that seat out of the sprinkler. We know we need 7 psi, has always been the historical minimum. Single interlock systems convert to wet pipe systems upon operation of the detection. Therefore, the air pressure or nitrogen pressure really doesn't come into play. And old systems, Reliable had one years ago that used 30 ounces of air. That was a very, very small puff of air in the piping. The problem is it's very difficult to manage low pressure alarms when you're in those low ranges. So again, all it's saying now is look to the manufacturer to give you some guidance on those single interlock. This 8615 is regarding antifreeze and some of the new products that are available out there. When I look at this, I just think, we do shop drawings. This information is all on the shop drawings, or should be on the shop drawings. Now we've got to go out and hang a placard on the system. Sometimes I think we go placard crazy in this industry, but regardless, you will be required to hang this sign out there. And the key thing here that changed is the words minimum use temperature used to say concentration by volume. Right, so we used to be able to change the percentage of glycerin and propylene glycol and theoretically affect that freezing range. All of the new products, the listed products, are going to tell you what the minimum temperature it's listed at. And so this is just essentially a nod to the fact that we're not going to be able to change that rating by adding more of something. Pretty straightforward concept there. A new area that does not require sprinklers. Very common to see dryer duct vents going from the laundry room out to the exterior wall. Oftentimes we're running cabling in there, maybe even running fire protection piping in those soffits. And in a combustible environment, if it's built with wood, could you essentially be creating a space that needs sprinklered? Nobody wants to be doing that, but we now can see that if we're doing this properly, we have this 160 cubic foot requirement that we can now point to the AHJ and say, here's why we're not protecting inside this soffit. So that's nice language to have added to our repertoire. Sprinkler location requirements. 922, we've added the word exterior platform. So again, one of these semantic debates, whether or not exterior docks, the word exterior applied to platforms, it now clearly does. In the past, you may have attempted to do something like an area below the stage in a school that had no storage in it, was non-accessible, but perhaps it was combustible. And you may have pointed to this and said, this is why I'm not sprinklering that area. Now, very clearly, this states that these are for exterior platforms. Could you build an interior platform still that does not require sprinklers? Yes, you could, but you would now have to go back to 9.2.1, which is that long list of areas that don't require sprinklers in order to address that interior platform. So very clearly now exterior related. Sprinklers shall be required for portico shares that are located directly below floors. So imagine you're pulling up to the nursing home or whatever type of occupancy it is, but instead of a carport type of portico share, it's underneath an occupied part of the building. So in the past, it could have been perceived, and most likely was, as if that was non-combustible, right? It said non-combustible portico shares did not require to be sprinklered. Again, now making perfect sense in my opinion, that if there is occupancy above it and you're essentially under a building, and that's what we're talking about with occupancy above, those areas must be protected. This is a really interesting one here. It again seems kind of straightforward, right? Sprinklers should be installed under projections 4 feet where combustibles are stored. In the 2007 edition of NFPA 13, any projection where combustibles were stored, regardless of depth, required protection. In 2010, it was changed to 2 feet, and it has stayed 2 feet since then. Now we see that it's going out to 4 feet. Well, was it really 2 feet? If you were to go through NFPA 13, 2019, again, which I did page by page, it actually appears in 2 spots. One says 2 and one says 4. So the rule that's the requirement for the 2 foot has been removed in the 2022, and it is now 4 foot where combustibles are stored. Again, just some cleanup, and some of the things like that, where things appear twice in the standard, that was an offshoot of the complete rewrite of the 2019 edition. So there were bound to be some errors, and we're seeing some of those kind of get cleaned up. Sprinklers shall not be required in closets and pantries where other governing laws, etc. So other standards, maybe it's NFPA 101. I don't know what they are, but if there are other recognized standards that say that these closets don't need to be protected in pantries, this is the allowance for an AHJ to allow you to leave those sprinklers out. You'll notice that it's not specific to hotels, motels, or anything. It's any closet or pantries that are addressed by another NFPA standard. Furnitures and cabinets. If you've been in a modern hotel room, we spend a lot of time in Marriott's ourselves. Very common to see a big piece of furniture that encompasses the wardrobe, right? The coffee maker, the microwave, the desk. They bring these in, they bolt them to the wall, and even though it's a quote-unquote closet, the standard is now cleaning up that these move-in pieces of furniture do not require sprinklers. They do remind us in these sections, however, to make sure that the sprinklers we put in the room are spaced to the back wall of that environment. And then 9.2.10, this again, a semantic debate. The original proposal said small temporary occupied enclosures. The word that they were looking for and has been cleaned up here is temporarily occupied. And when we talk about this, we're thinking about terms about areas like a hearing test booth that you walk into, or a breastfeeding enclosure in an airport. You'll see these along the wall. So there are some rules about when these need to be sprinklered, right? What size of what size of room can this be in order to leave that sprinkler out? Those are going to be defined in those sections. So the only reason that I put this one in here, and you'll see highlighted there, section 9.4.1.2. So what this is saying is that this sprinkler, this in this specific instance, this sprinkler was not listed to be used in the environment we're putting it in, but we're going to allow it in accordance with 9412. And what 9412, if you don't know what this one is, you're going to want to make sure you lock this one in your brain and highlight it. It states that sprinklers can be used outside of their listing when specific when specific situations exist that require unusual water distribution. Okay, so an example of this could be something like putting a pendant sprinkler in the sidewall position in a duct, in a horizontal duct, right? We put a sidewall in there, it's going to spray right to the other side of that small duct, and it's just going to create a flood in there. What you might want to think about doing is throwing some water sideways off of that pendant deflector in the sidewall position. This would be an opportunity to say, hey, this is better fire protection, and this section 9412 is my allowance to do that. You might not always win, but be aware that the opportunity presents itself there. Elevator machine rooms. This section was formerly called elevator hoistways and machine rooms. That was the title. For some reason, maybe it's an architectural concept or a building code concept, we've now have to identify machinery spaces, control rooms, control spaces, etc. You probably see these called out on the plans. Again, why we have to do this, I'm not quite sure, but it's there. The couple things that have changed, the temperature requirement used to state they needed to be intermediate. That may not have been enough. I've been in some very hot elevator machine rooms. So for the standard to say, use this temperature sprinkler in this environment, probably not a good idea. We now see that they're not going to specify the temperature rating. They're going to leave that up to us. But what they are going to tell us is the sprinklers in those environments will be standard response sprinklers. Unless the requirements of et cetera, are met, ordinary or intermediate temperature sprinklers shall be permitted. So what did this used to say? It said ordinary and intermediate temperature sprinklers shall be required. Again, poor wording. We kind of knew what we meant to say. We just didn't say it properly. So now what we're going to say is you have your choice of ordinary or intermediate sprinklers. You're permitted to use either one throughout the building. We're seeing a lot of movement these days, particularly in the residential world, of intermediate temperature sprinklers being installed throughout environments. And now that this language is cleared up, that should be a little easier pill for the AHJ to swallow. So here's, you see the word global on this table formatting. And we're just going to walk through one example of this, but it's going to cut across a lot of ground in the other obstruction tables and the way tables were formatted in 13 historically. So imagine the standard beam rule that we use. How high can our deflector be above the bottom of the beam given the distance away from the beam? Less than 1 foot, we have to be even or below the bottom of the beam. So what did it used to say? There it is, 0. Now we go to 1 foot to less than 1'6". What it said is that you must be 2.5 inches above. The strict language said you must be 2.5 inches above. Well, that's not true. You had to be 2.5 inches or less. I mean, the better spot would be further down and allow us to spray better under that beam. So, so these debates have been swirling in the committees for years and years. Finally, have come to consensus that the better way to say it is what is shown there. Less than 1 feet, we're 0 inches. We got to be equal or below. If we're 1 foot away, we're 2.5 inches above the bottom of the beam or less. So that's lower to the bottom of the beam, et cetera, et cetera. And all of those tables for EC sprinklers and ESFR and all that are going to be reformatted to make this just a little bit clearer. Another kind of quasi-global addition that's been made for narrow hallways up to 6 feet wide. right? Again, there's some limitations here. You can have a maximum 12-inch obstruction in the center of that hallway, and you can have a sprinkler dead center on that obstruction as long as you're 12 inches away. That is now going to be allowed. And you'll see again, there's a nice diagram that was put together to show exactly what we're talking about there, just to give us some relief for those narrow corridors that you may end up. I mean, let's face it, if they put the lights at 10 feet on center, you don't want to be going 10 feet on center with your sprinklers or doing some kind of crazy layout. So that's, again, just a little allowance to account for things like that. Two additions to the historical places where we can use sidewall spray sprinklers, right? We talked earlier about exterior projections. So now we know what that is, right? Projects out from the side of the wall and is capable of collecting heat. We identified that earlier. We can now say we can use sidewall spray sprinklers for that. And in the event that someone says we don't have direction on how to handle car stackers, I'm not going to say that it's clear as mud, which it kind of is, but we now have the allowance to use sidewall spray sprinklers in car stackers and car lift systems, as long as we provide them under each level of cars. No real guidance given on, again, what that occupancy is. Is it ordinary, group 1, group 2, extra? At least in my opinion, there's still some work to be done here, but now we're seeing that these things have to be protected. We've got to give some direction to the contractor on how to do this. So again, now can be used for car stackers. This was an interesting one as well. If you're in a building that has Q decking or pan decking, if that's what you want to call it, the corrugated metal deck, and you, for some reason, for clearance reasons or whatever, had to throw water outward from a beam, let's say, and you looked at that corrugated deck and said, I can't use sidewalls here because they're not listed for this. The standard is now telling us again that when those channel depths are up to 3 inches, that you can consider it a smooth ceiling and use sidewalls for that application. So that's just kind of a nice little addition as well. We now move into extended coverage, upright, pendant, and sidewall sprinklers for the suspended or floor-mounted obstructions. So think in terms of the privacy curtain that's hung around your booth at the hospital there, or perhaps it's a pony wall coming up from the floor. We see these new requirements provided for ordinary hazard when using the EC sprinklers. We don't see them for standard spray for ordinary hazard. And the only thing I can think of there is that the drastically different spray patterns that come off of these deflectors must account for this allowance in the EC flat spray world to get some water on the backside of these obstructions. And you can see the rules are specified there. If you're more than 6 inches off the center line, you have to be 18 inches or higher above the obstruction. If you have a narrow obstruction, 12 inches or less. If you're within 6 inches of the center line, you can bring that sprinkler down as close as 6 inches to the top of that obstruction. Some new rules provided there. A nice reminder that for EC sprinklers, for rubber tires, that 18-inch traditional clearance, right? We have 36 for CMSA and ESFR, but for CMDA and these other types of sprinklers, you could have thought maybe that 18 inches was all the clearance you needed for rubber tires, and rubber tires is always going to be a 36-inch clearance to the deflector, regardless of the sprinkler type. Maximum distance between sprinklers. This again was an interesting one in the world of sidewalls in particular. When you had sidewalls that were throwing out toward another sprinkler, maybe another sidewall sprinkler perhaps, the old wording stated that you could not have a sprinkler within the coverage area of the opposing sprinkler. The debate always was, is that the maximum coverage area or is that the hydraulically calculated coverage area? If I have a sidewall that can do 16 by 16 and it's also listed to do 14 by 26. Am I using the 16-foot throw as my mark to that sprinkler on the other side, or am I using 26? It was not clear. And there was a lot of debate about this, and finally we came up and just said, look, let's just make it a set distance. We're going to use 12 feet, and so that is now the rule. And then another addition was the allowance for light hazard EC sprinklers to be used below overhead doors, not in a storage occupancy, but in ordinary hazard areas. Clearance to storage. So imagine you've got a small closet or a storage room. You've got shelves along each wall. You're having trouble getting your sprinklers located in there because of lights or whatever it is. Basically what it tells us, we've had this for standard spray sprinklers. We've now extended it to extended coverage sprinklers. If the shelf is under the sprinkler, if the sprinkler has to be moved off to the side for some reason and the shelf is under the sprinkler, you must maintain that 18 inches to the top of whatever's being stored on that shelf. If the sprinkler is pulled out off the edge of the closet, in other words, it's not over top, then you can have shelves all the way up to the ceiling, is essentially what this is saying. So again, the shelves can be located above that location. So this is a pretty straightforward one. It was in one location mentioned, the 36-inch. All we've done here is we've added some new wording and we've cleaned up some figures to indicate that in a peaked ceiling area for residential, regardless of how you place those sprinklers, you shall have a sprinkler within 36 inches of the peak in some form or fashion. Pendant residential, recessed, pendant, and concealed. The reason concealed is highlighted there in the 2019 edition. There was some concern leading into that adoption of that particular year that the concealed sprinklers weren't going to do the job properly in very deep beams, up to 14 inches deep. So in 2019, that got lowered to 4 inches. And the reason it was 4 is because we've always had a 1 to 4 deflector distance for residential sprinklers. That was the magic of it. So for lack of better information, in the 2019, it was reduced to 4-inch beam depth for concealed. Future testing that's been done and people just looking at it in different ways, we're now going to say concealed sprinklers can be installed in those 14-inch deep beams. So that's good to have back. CMSA sprinklers, a few years back, I don't remember if it was 2013, 2016, we saw a lot of baffles being added to different types of sprinklers. They've now been added to CMSA sprinklers to give us some break when the sprinklers are closer than 8 feet on center, and the rules are spelled out on how long they have to be and how deep they have to be. So this requirement for ESFR in obstructed construction to be in each channel where the structural members exceed 12 inches is not new. What was missing is what happens to our hydraulic calculations at that point when the standard says ESFR cannot be closer than 8 feet. And that was not a cold solder issue. That was an acknowledgement of the fact that if we set too many ESFR sprinklers off, we may over challenge our piping network. So what we're now saying is if they are separated and they are complete, the line of sight between those sprinklers is completely broken by that structural member, that they can be less than 8 feet apart. However, within the channels, along the branch lines or along the spacing within those channels, you still must meet the minimum and maximum spacing requirements. And you're still going to do a 12-head sprinkler calculation in that environment. Previous editions stated that ordinary temperature ESFR sprinklers shall be used unless near a heat source. This is just basically saying if you want to use intermediate throughout, you may now do that. Again, since 2016, I believe, might have been 13, we've been permitted to protect light and ordinary hazard occupancies with ESFR. People knew that it was happening. There was really no reason not to allow it. What was missing was how do we handle obstructions? And do we have to, in a light hazard occupancy, meet all of the heavy ESFR obstruction requirements? And the answer is no. You now, in those environments where ESFR is protecting those occupancies, you just basically divert back to 10.2.7.2, which is the basic rules for light and ordinary hazard. This is an interesting one again. I didn't even realize this was going in there, and now saying that baffles can be allowed to place ESFR sprinklers closer than 8 feet on center. It doesn't tell us what to do for hydraulic calculations, though, at least that I could find. So I think there's got to be some thought given to what are we doing there, and is this really a valid use of baffles? Bottom chords of bar joists. So historically, 1 foot off the edge, regardless of the width. Testing has been done to show that those rules were a little bit draconian. And so now we see that if the bottom chord is 6 inches or less, we'll be able to pull that ESFR sprinkler as close as 6 inches to the edge of that typically flanged lower member. The second part of this needs reworded. Because where bottom chord is 24 inches or less, well, 6 inches is less than 24. By the way it's written, you'd still have to be 12 inches off. That obviously was not the intent. The intent is between 6, or let's say over 6 and up to 24, you'll be 12 inches off. So that needs cleaned up a little bit in the next edition of the standard as well. Sprinklers, ESFR sprinklers on branch lines. If the lines are 4 inches and smaller, you can directly mount them. I think we've been doing that for a long time. I guess the question is, are we doing 6-inch lines? If you are, if that's what you're calling them, you need to offset them 12 inches away from the pipe, or sprig them up, stub them up a minimum of 12 inches above the pipe. I think instead of saying branch lines in the title of this, we should just say ESFR sprinklers on pipe, something like that. So there is my alarm for 5 minutes to go here. Do we have questions that need to be answered at this point?
Yeah, there's a few questions. Let's start with what should be a quick one. You talked about the allowance for C factor of 120 when using a nitrogen system. Does that apply to dry pipe and double interlock pre-action systems, both of those?
Yes, that's it. Now it may be in the dry pipe section of the standard, and we see a lot of requirements in the dry pipe section that are later referred back to when we start talking about double interlock. But it's just important to realize that double interlock pre-action system is nothing more than a dry system with a detection component on the front end. So as it sits there, it's acting and is designed just like a dry pipe system.
Okay, and then a couple of storage questions. First one, in a situation where there's beams spaced at 6 feet apart, your typical ESFR sprinkler spacing is probably then, call it 6 by 10, so 60 square feet each, and flowing 12 sprinklers, that's 720 square feet of sprinklers flowing, right? So it's not the 768 magic number that's been there. Does NFPA 13 address that situation?
Yes, and what it says is that the requirement to calculate a minimum of 768 square feet is waived.
Okay. And then one final question. I couldn't remember the discussion myself, but maybe you will. Was there any discussion in the meetings that you remember being at about cannabis growing facilities and protection of portable racks in those facilities?
So there is a new standard that is been I guess, authorized, for lack of a better term, by NFPA. It's Nfpa Standard 420, which may ring a bell, is going to start identifying the rules for protecting cannabis and cannabis growing facilities and things like that.
Yep, and it looks like that's still, so they did a first draft meeting back in November of last year. Looks like they still have a little ways to go to have a standard published, but yeah, that's under development.
Okay. Under development.
Yep,
Okay.
that's it for questions so far.
All right, so I appreciate everybody that's hung on this long. I'm hoping you can hang on till the rest. I'm really working hard to get through these, but again, if you do not cannot stay on, please double back to the recorded. We're going to continue on, and we'll get through the rest of these. It will be available for future use to you. So, a new rule, conveyors. So in the ESFR world, now I personally think this should probably be moved into the general rules for storage. We may look at doing that because obviously we have conveyors in CMDA and CMSA designs as well. But right now they've been added to the ESFR section. There are 6 rules to determine whether sprinklers are required and what type of sprinklers they need to be. They're very easy to understand. Again, the question in the past has been, what type of obstruction is this? Is it a standard obstruction that's defined already in the standard? Is it perhaps, as some people may have thought, just part of the storage itself and didn't need anything? But again, now we're going to see if it's a conveyor, you got some really nice, clean rules on how to protect those, and again, what type of sprinklers to use. One thing to keep in mind as you read those 6 things. It's primarily talking about where you have high piled storage below. So if you're out over the loading docks and there's no high piled storage below, make sure that you're applying the correct rule. At that point, it may save you some sprinklers down the road. Attic sprinklers, this is interesting. Again, we were like, why does this have to be in here? There seemed to have been a perception that because we have attic sprinklers that you must use them. And that was never the case, right? Attic sprinklers are there for convenience. They're better protection. Let's not make any mistake about that. They also allow the use of CPVC piping, but you are not required to use them in an attic environment. You're permitted to use them. Again, previous wording here was that when a sprinkler is removed from a fitting, has been now clarified to say that when a threaded sprinkler is removed. So we see the Victaulic V9 grooved end sprinklers. There are probably some other ideas out there for connection methods that will not stress the orifices when sprinklers are put in or taken out. So again, this is for threaded sprinklers only, and the only exception is the dry barrel sprinklers, where the water seal orifice is kind of separated away from the sprinkler itself. Those can be removed and reinstalled according to the manufacturer's requirements. Previous language here would lead you to think that when you used trim rings and concealed plates, cover plates, that they must be listed with the sprinkler. Well, the intent is that they go on when the sprinkler goes in. So quick rewording basically says that the sprinkler shall be installed with the escutcheon that is part of its listing. The weather temperature. So who determines? When do we determine when we need to put in a dry system that's on the outside of the building because the temperature may get to a certain degree? Where did that information come from? There were historical thermographic charts in the standard that, put the U.S. about the size of a playing card, and you were supposed to figure out which side of a particular line you were on. So now we've cleaned that up and basically said you shall get the information from an approved source. Remember what approved means. The AHJ must approve that. So if the AHJ says that Floyd the barber knows what the temperature is going to be because he's lived here for 100 years, I suppose that could be an approved source. Realistically, though, what is it? Is it the NOAA, the National Oceanic Administration? Is it the Weather Channel? At least we have to go somewhere to get this information. 16 covers a lot of ground. Installation of piping valves and appurtenances was where we're at. We talk about pressure reducing valves, and we have thought and been told that there has to be a way to test these devices. We now have language that tells us what this looks like. We've reworded the requirement. We now know that for every 250 GPM of demand, we're going to provide a single 2.5-inch hose. So just divide by 250, that's your number of hose. If the valves are existing downstream for some reason, those are usable, and it kind of makes sense. And then other means, this is just kind of the opening to get creative, are acceptable, provided you don't have to modify the system. And I think what they mean by that is you're not going to say, I'm going to take this check valve out and reverse it, right? That's a modification to the system, will not be allowed. Wow, a very similar looking slide. In fact, it's identical for testing backflow prevention devices. Kind of small stuff here. When you're setting pipe into a saddle, typically we've U-bolted those in or somehow anchored those down. We now have an allowance to simply let it rest in the pipe in the saddle when the pipe is not subjected to a net vertical upward force. I had to look that up and see what that meant. And when you look it up, what comes up is a lot of talk about buoyancy. So if you've ever been in a swimming pool and tried to take a basketball or some sort of a ball and pull it under the water, you're fighting that net vertical upward force. So just be aware that you're not required necessarily to anchor that thing actually into the saddle. This is an interesting one here, and it took me a while to kind of think this one through. So what 18596 says is that the weight of the branch line shall be added in the zone of influence to all the way back to your main to determine the spacing of your lateral braces on your main. It's to pick up that weight of those branch lines coming in. What it's saying now is that if you don't want to do that, you can go out to your branch lines and brace them at 80 feet, take some of that load with longitudinal braces, essentially takes that load off of the lateral brace that's on the main. And I'm thinking, well, why would you want to do that? Well, it's possible that maybe you can't even, depending on the weight that's carried on each one of those, you may not have an attachment method that can carry that weight. So this is now saying if that's the case, then simply longitudinally brace those branch lines at 80 feet on center and allow that weight to essentially be taking off the lateral braces. Maybe if those lines are big enough, this might be a cheaper route to go than drastically cutting down the spacing of the lateral braces, excuse me, on the mains. Seismic coefficient table. This is going to mean something to structural engineers and perhaps the guys who are writing the calculation programs for seismic bracing. But let's face it, seismic requirements have matured in the last 40 years. And they've gotten very, very difficult. But what we now have is a table that basically gives us a site-specific coefficient when the AHJ approves it. And it also gives us some relief for those braces that are less than 75 feet, 75% of the height of the building. So as you work your way closer to the ground, those forces decrease. And this is just simply an acknowledgement of that you get to take a little break on that seismic coefficient. HVLS fans, there should be no surprise when those are in buildings, and we see them used in a lot of places now. They must shut down. They must depower when the water flow indicator goes off or the water flow device goes off. All this is saying is that the tie-in to making that device shut down when you have an NFPA 72 approved code, it's got to be tied into it. Just kind of makes sense. Single point density. So we may not heard a lot about this. We started moving this direction a few years ago with the truncated curves and all of the storage areas and even some of these others. It's here. It's not complicated. It's not all that harmful. I think it actually will simplify things a little bit. When you have areas that do not require the 3,000 square foot design area, you're simply going to go and pick the traditional 0.1, 0.15, 0.2, 0.3, 0.4, right? The traditional, and you're going to just calculate. You don't have the option anymore of sliding up the curves. It solves some problems, but it was kind of a remote situation. So you've got that one at the lower end. If you have unsprinklered combustible concealed spaces and you need the 3,000 square foot design areas, you're going to have those densities that are given down below. All of the old information will remain in the standards, probably for a number of years, with now the new headings that these are only to be used for the evaluation of existing systems. So again, new systems, you're going to be looking at essentially just a single point density. Okay, the room design method. Where does this come into play? So for an NFPA 13 residential design, you're going to either be a 4-head demand, or if you got the unsprinklered combustible concealed spaces, you're going to be an 8 sprinkler demand. Well, look at that 8 sprinkler demand and see if the room design method might make more sense. And this is the allowance to be able to do that. Protection of storage. This again, just an allowance to acknowledge the fact that there are sprinklers out there that can do things, are listed to do things that you typically can't find in the NFPA standard. And the most prevalent example of that is the ability to protect 43 feet of storage in a 48-foot building with some specifically listed ESFR sprinklers. You can't find that requirement in NFPA 13 anywhere else. And we've had that around for a long time. It's surprising it took this long. This, again, just a way to say, hey, this is how you apply that information, Mr. Fire Marshal. This is where this is being allowed. Again, general requirements for storage. The commodities are now clearly listed, class 1, 2, 3, 4, and work your way through the 4 plastics categories. Very clearly now presented from lowest hazard to highest hazard, right? Class 1 all the way out to exposed expanded plastics. No longer can someone debate that. Well, they may be able to debate it, but the standard will tell them which is which, because there has been some debate about particularly the last 2 exposed plastics, which one is actually the worst. And then again, just a statement that we all know that NFPA 13 is a minimum requirement standard, and if I want to put ESFR in light hazard, I should be able to do that. If I want to protect class 1 with ESFR or whatever, or a class 4 design, I should be able to do that. So again, very clear that that's the case. Plastic pallets, right? We've had rules for plastic pallets for a number of years. When you have this plastic pallet, you go up 1 class, 2 class, whatever it is. Now you're going to not only need to find out if they're plastic pallets, you need to find out what specific type of plastic it is. If they are other than those 2 listed, the polypropylene or high density polyethylene, you may be having to do something more than what was already there. So just be aware that you now have to start asking a few more questions if you're in this storage world. So again, interesting. Words mean things. There was a statement or a section earlier that talked about movable racks. Well, every rack is movable. It's just you'd have to unbolt it from the floor and essentially move it, right? That's the difference between movable and portable is all they're trying to address here. So if they are portable, they're being rolled around. You need to look at them because they can be butted together. You need to protect them as though they are multiple row racks, which is the same rule essentially for movable. Here's an area to be very careful about, in my opinion. The default position of NFPA now is that everything is considered solid shelves. I mean, that's the default, and this is the wording, right? Double row racks without solid shelves shall be considered racks with solid shelves. So they're saying, unless you meet these requirements, you will protect these as though they're solid shelves. So it's kind of a weird way to do it. FM does it a little bit differently, but the end result ends up being pretty much the same. If you do not have the longitudinal flue spaces in double row racks, you're looking at those as solid shelves, unless there's a limit to the storage height of 25 feet and you have nice transverse flue spaces at 5-foot intervals. Then you treat them as open shelves. Multiple row racks, again, default position shall be considered racks with solid shelves. In this case, with the multiple row, transverse flue spaces and longitudinal flue spaces at 5-foot increments, 5-foot cubes. Maintain those, you're good. You have to have the transverse flue spaces in any regard. You're allowed to leave out the longitudinal and still treat them as open row racks as long as you don't exceed 20 feet deep and you provide a 3.5-foot aisle. And that rule for FM would be an 8-foot aisle, by the way. So as long as you've met that, you can treat them as open. But this is something you don't want to miss when you're talking to the building owner. You've got to ask them about these flue spaces. What does this storage look like when it's loaded in there? Because you just can't look at it and go, it's rack storage anymore. Because if you miss these rules and you have to move from a design that didn't have solid shelf racking to a design that does, your boss is not going to be very happy. So just be aware of those. And then finally, again, another reminder that, slatted shelves shall be considered solid shelves unless you meet these requirements. If the openings are wide enough to meet the requirements of open, then of course it's not a solid shelf. Or if you use one of these two protection schemes way out in Chapter 26, you can protect slatted shelves in that fashion as well. So again, you're still going to be going back and forth between chapters. A lot of that has not gone away. Slopes over 2 and 12, can we protect them in a storage occupancy? Generally, the answer is no, but you actually can, right? If there's a specific section in the standard that says you can do it, sure. Whether they're in there, I'm not sure, but I think it's just an acknowledgement of something maybe to come. But the second one there, when you use one of these 3 options, and we've done webinars on this very topic about these in-rack sprinkler options independent of the ceiling design, right? This is the virtual floor concept that is now allowed by the standard. And you do not store above the highest level of in-rack sprinklers, then it doesn't matter what's happening up at the roof, because that level of in-rack sprinklers is designed to protect everything below it. We're no longer relying at those sprinklers at the roof. So if we've got an old GSA sawtooth roof going up and down that they want to convert into storage, this is a perfect opportunity to be able to do some style of protection that doesn't require them to change the look of that roof. Again, 20.19, protection of racks with solid shelves. This is where you would go if you missed these the slides that we looked at a little bit earlier. I'm not going to go into all the rules, but let's just say they're not slight. It's a lot of sprinklers that have to be put in there at a lot of different levels. So again, the word of warning is do not miss this in your estimate or your design. Again, those were in Chapter 25, which we're going to talk about in just a second. Those have now been all moved up into Chapter 20. Cmda sprinklers, again, we're in the single point density world that we talked about, very similar to what's happening with the light, ordinary, and extra. If you're doing protection of looking at existing systems, you're going to use the old tried and true rules, and those single point densities do not apply to plastics at the current point in time. All of those in that area, and particularly for the palletized, is all built around a 2,000 square foot remote area. When we move into rack storage, also single point density, where you're over 12 feet and up to 25 in single, double, and multiple. Multiple is further broken down by the depth, right? Whether they're 16 feet or up to a maximum of 25 feet, whether the aisles are 8 foot or less than 8 foot. There's a lot more selections that are happening in there. And it's not a set remote area. So it's not 2,000 all the time or 3,000 all the time. It jumps around depending on what you're protecting and what sprinkler temperature rating that you select. And just like the other ones, if you're doing evaluations or modifications, you'll follow the old rules, which will remain in the document for a period of time. Rich Gallagher, a gentleman of Zurich Services Corporation, recognized that we had about 6 pages of ESFR sprinkler requirements that essentially were all the same. And so what he did, and this was great work, boiled those down into one table. I mean, when you look at this chapter 25 using ESFR sprinklers, it's about 4 pages long now. It was just a great move to get all of this built onto one table. It's going to make things much simpler from a design standpoint. Chapter 25. So the way NFPA 13 does this now is they put a little N in front of everything that's new in a chapter. Well, if you look at chapter 25, every item in there has an N in front of it because that entire chapter was rewritten. It's not necessarily new information, it's new formatting. So I'm not going to go into all the details because it's pretty much the same as it was in 2019. This was, and again, a shout out to Wes Baker and the folks at FM essentially took this on. There are 167 figures and tables in that chapter, and what the intent was to relate as much of the text to a figure as possible so that you could look at the figure and understand what the text meant. It's very difficult the way it was done in 2019 to pull all of that together, but that's now what's happened. So again, not necessarily new information, rewritten information. We're getting close to the end, folks, trust me. Special designs of storage protection. So chapter 26 in 2019 was called Special Occupancy Requirements, and what was in there was 34 occupancies that had another NFPA standard. These range from dry cleaning facilities to nuclear power plants. And what the committee did in 2019 is they went to those standards. Let's say you went out to the 909 for cultural resource properties. There may have been 8 statements in there about fire protection. They yanked all of those into NFPA 13, and they did that for all 34 occupancies. They've now retracted from that position and they do it by reference. They've moved it all into chapter 27. And all it says is when you have one of these occupancies, go to this standard. So again, it's a little bit of a cleanup, a little reversal of what was done in the past. 1 second. Thank you. Pardon that. Now, again, those have been moved into 27. So there are some things that were moved in these special designs of storage protection. Look for these. When you hear these, think about where they fall. Do a quick search. If you go into if you have the PDF documents, brilliant way to get in there and just search for automotive components and look for all those requirements because they can be substantial. That's one of them that's in there. ESFR protection of specific automotive components. Some retail storage. Let's say anybody's familiar with the Container Store. I mean, what does that thing look like? That's not your grandma's mercantile store anymore. So we've got rules, very specific rules for retail storage of that. The old 20-foot and 20-foot 7 0.6/2000 density systems for areas with slatted shelves. That was something that was tested and came about and has been in the standard for a long time, but it's a very specific style of protection that's required to do there. And then here are some other ones, the baled cotton, the document storage, et cetera, et cetera. All of these have protection requirements within them that you need to be aware of. Phantom flow, you guys have dealt with this before, but this phantom flow, what was the idea here? Not real sure. The only thing I could come up with is if you had a small office on the exterior wall of your warehouse and you had to take a main over to it to drop down and feed it, the intent seemed to be that they wanted a minimum of 150 gallons going down that main. Let's say you had 3 sprinklers out there. The intent seems to be that they wanted 150 going out there. Why we're in the business of saying we need to provide pipe sizing for future stuff, I don't know, but the reality is it's in there. The problem was they said that you had to add the additional gallonage at the very furthest branch line from the source. If you've ever done hand calculations, and shame on you if you haven't, by the way, when you do hand calculations, you would realize that if you added the gallonage at the last branch line from the source and worked your way back through your calculations, you would end up with more than that 150 gallons. You'd have to K up those branch lines all the way back. So a lot of discussion went on about this, and now we've changed it to say it's the connection closest to the source. So all we're trying to do again is you're going to calculate, let's say you come up with 96 gallons, you know you need 150, you're going to add 54 gallons as a hose stream allowance, or however you want to put it into your calcs. You're going to roll that through that main just to make sure it's sized properly, maybe for some future use. This again, another interesting one, calculation of design area. I couldn't believe that what I was hearing, but people had this perception, and I can't say they were wrong. If you have a sprinkler that's near a wall that's protecting 15 by 15, but you're 3 feet off the wall, people were taking the design area beyond the wall by 12 feet and including it in their 1,500 square foot office remote area if it was an office environment. They were going beyond the wall with their dotted line of their hydraulic calculation remote area. And this is now very clear that it's, if you are up against a wall, it's the wall area. Regardless of how much water may or may not being wasted out of that sprinkler, you do not get to go over the wall where water can't spray. Seems, again, I guess it wasn't clear. Some interesting information, again, a couple additional locations when we talk about friction loss. Item number 10, tapered reducers, concentric reducers, I guess eccentric reducers. I never thought about it, but now clear that we don't need to include those. An allowance to use that C factor of 120 when we refer back to the stuff we've. And then here's our last slide right here, just a reminder, not necessarily new information. A lot of debate whether or not you actually have to perform a trip test on your dry system at the end of the project, particularly when you use the hydraulic calculation or the fluid delivery calculation program. Well, people were saying, well, I don't have to prove that. The calculations prove it. You may not have to prove it, but you still have to do the test. And the test is done to establish a baseline for the future. Right. And what the follow-up to this says, okay, if you did calculate it, you're exempt from the specific water delivery time, but you still have to trip test it and you still have to time it out and prove that. And one thing to bear in mind here is that those calculation programs are designed and required to be accurate within 10%. So if you calculated at 60, theoretically, the maximum you should be able to go to would be 66 seconds. This exempts you from that. But just remember that if you're out there 70, 80 seconds, I mean, let's realize that you got a problem on your hands. Let's do good fire protection and make sure that we address what may or may not be causing that situation. So again, we went 25 minutes past the hour. It was a long one. There's a lot of stuff in there. At this point, we're going to open it up for any questions that came up. Steve?
Yeah. So got a few additional questions. One question points out that there's a little bit of difference in something that should be similar between the allowance for 3-inch depth of pockets in a corrugated metal deck versus the definition of a smooth ceiling up in Chapter 3 that talks about no irregularities greater than 4 inches, right? So when we talk about corrugated metal decks, that's a 3-inch depth allowed. When we talk about a smooth ceiling definition, that's a 4-inch depth allowed. do you have any reason? Is there any good analysis or reason why those things are different, or is it just the results of where things have ended up?
Yeah, that's exactly what it is. It's the result of the committee process and the fact that these end up in different areas. The 3-inch rule, I actually put that proposal into NFPA, and when I did it, 3-inch was kind of a number that seemed to be out there for the average, like real deep pan decking, right? And so it was kind of like, let's use 3. I may have even submitted 4 and somebody broke it back down to 3. But that 3-inch rule is specific to the use of sidewall sprinklers, right? It was not intended to define a smooth ceiling. In fact, the wording says shall be considered as smooth ceiling for the purposes of using sidewalls. The 4-inch rule and the whole lumps and irregularities, I think there was just no correlation between those two. They're related, but they're unrelated, if that kind of makes sense.
Yep. And there's a related question that's really getting at what you just talked about. You talked about depth of 3 inches for corrugated when using sidewall sprinklers, but there's an allowance for using sidewall sprinklers for exterior projections that one would think is limited to smooth ceiling construction. So is there a 4-inch depth allowed at that point? Right. It's a little bit confusing, and probably for the inch difference could use a little bit of work in the next edition to make it more consistent.
Yeah, I don't disagree, and it seemed to me there might have been a little bit of indication that he was talking about like a balcony above, where oftentimes you'll see 2x12s used as with no sheathing on the bottom, and can we put sidewalls out underneath those? And I don't recall where in the standard that is. I actually was looking for it and I couldn't come up with it, but and it may even be in 13R. I can't remember for sure, but I know that it's allowed, but the joist depth is, I want to recall, is limited in that application. That sounded more like the question to me was for the exterior projections, can we put it out under a joisted area? And I mean, I think the answer is yes, with the requirement that the joists are a set depth, and I couldn't find that, and I apologize, I don't have that answer.
So the question earlier about the C factor 120 for dry and pre-action systems, that's specifically covered in table 282481 in the back of the hydraulic calculation section. Just a note from one of the viewers. There's a question related to the 768 square feet being waived for closed spaces with beams. Why wouldn't that be waived where you have baffles between the sprinklers?
The reason is that if you think of that channel that's created by the solid structural members 12 inches or deeper, the heat plume coming off that fire is going to run down the channel. And only until it hits a stop at either end is it going to then billow down and go into the next channel. If you have simply an 8-inch long or 2-foot long baffle or whatever the length that they're proposing, that heat plume is going to it's going to go around it. And all of a sudden you're back into the world of the potential of setting off too many ESFR sprinklers. So I mentioned that there's no direction on how to handle the hydraulics when you're using baffles that I could find. I think that got added without a lot of thought to what do we do for the hydraulics here? Because the whole idea of being less than 8 foot, as I mentioned, was never a cold solder issue. It was always we're going to set too many sprinklers off. The understanding seems to be that when you're in these obstructed construction long channels, that's not going to be an issue. You may set off more than 4 in a row, but the standard doesn't really address that. But a baffle doesn't create a solid barrier or that solid channel like a I-beam does, right? Those baffles just simply break line of sight over to a sprinkler that maybe is too close.
Yep, and that line of sight is all about water spray from one sprinkler hitting another sprinkler, and the allowance on the 768 square feet is about sort of the containment of the heat from the fire.
Correct.
Kind of two different things going on there. In 10.3.2, where it has the allowable locations for sidewall sprinklers, and it added in car lift systems, would that specifically include extended coverage sidewall sprinklers? Would they be an option for a car lift system?
My answer to that would be yes. And the reason I say that is without the, well, let me go back real quick. It was 10.3.2, right?
Yeah, 10.3.2.
Yeah. So that happens to fall under sidewall standard spray sprinklers. Yeah, I mean, he's right. It falls under sidewall spray sprinklers, not extended coverage. Now, that being the case, that's essentially maybe someone just saying we didn't know one existed, right? Why would you not want to use extended coverage in that application, particularly when you're getting a larger orifice and potentially a lot more water discharge out of it? So I think that's probably one of those ones that, again, needs a little bit of work. And maybe added to the EC section as well.
Yep. So 2 more questions, and then we'll end the marathon, right? Well, then they keep coming, so let's keep going. Would you consider, I think we're back to cannabis again, would you consider the growing of any plant on a movable rack multi-tier system to need an in-rack sprinkler system designed to storage requirements, even though it's considered an F1 occupancy?
I don't even know how to answer that, Steve, quite honestly.
Yeah, so I think they're 2 different things, right? I think the building code occupancy is not the NFPA 13 sprinkler protection requirements, right? I think it's a little bit apples and oranges. Whatever the building code calls it is not relevant to how NFPA 13 requires it to be protected, right? And so if it's deemed to be storage, which there's a discussion to have on that, which I had with AHJs, then you deal with it as whatever the appropriate classification for that storage is. But probably a pretty low classification, right? Something like that. But I think the analysis happens all within NFPA 13 of what is the commodity, right? And how is that commodity required to be protected? And I think with the reasonable, good discussion with the AHJ, you can get to a decent answer on that.
And then I thought it sounded like he mentioned plants growing. All of a sudden, does that become some sort of open top container? I mean, there's a lot of things that could come into play with that, and movable racks. I mean, there's a lot going on there, but you're absolutely right. I mean, at some point, in the absence of very specific rules, we have to do the best we can at applying the information that's available in 13. So you're right. At some point you just got to go, this is as close as we can get. And at the end of the day, the AHJ has to sign off on it.
Yep. There's a question about NFPA 13 moving to yearly revisions as needed due to technological developments. There's no indication that that's happening. It's a typical 3-year revision cycle, modified only by allowance from the NFPA Standards Council. So that's pretty set, no changes planned there. Fire protection guidelines for lithium-ion battery manufacturing, there was nothing that came in on that in the last cycle. Currently, a little bit of guidance on the FM side that one could look at, but nothing new came in this edition.
Yeah, and the other thing there too is 855, NFPA 855. Now, whether or not they were going to address the manufacturing of those batteries as opposed to the storage and the use and things like that, I don't know. But that would be another place to start watching for answers to battery stuff, is in NFPA 855.
And were there any changes related to smoke vents and ESFR protected areas that you can remember from this cycle?
No.
Okay, and that still is the question.
Yes, right now, what the standard says and has always said is that the standard does not anticipate the use of smoke vents, heat vents, and draft curtains with ESFR and really any type of storage. And that's the approach of NFPA is we don't want them there. We're acting like they're not there. What you don't get is what if somebody says you need them there? Well, if you do, you've got to treat them like a wall or whatever and start trying to figure out how to address it. But I think by virtue of the stance that NFPA has taken is let's force AHJs almost to get this thought out of their mind that they're needed. That's kind of my opinion on it.
Yeah, and that issue's been out there in the industry for, well, more than 20 years. I'll put it that way. And I think a lot of building and fire codes that might require smoke and heat vents have, over the years, provided allowances so those smoke and heat vents have higher RTIs, higher temperature ratings than the sprinklers that are there in the ESFR sprinklers. So in theory, if the sprinklers are working, the smoke and heat vents aren't going to operate. But this question, I think, is from a location where that hasn't happened in their building codes.
And
he's a challenge.
Yep, and you're right there. There is language in there that where they're present, and I just remember this, that the sprinkler or the links shall be high temperature and they shall be standard response.
Yep. Okay. Well, I think that'll do it. That was a great marathon presentation, and thanks for going through all that for everybody. It looks like there was a great crowd and some great feedback on it.
Good. Well, again, thanks everybody for attending and for pushing through if you did. Otherwise, we'll catch you on the other side.